Welcome to Core of Space, where we explore the mysteries of the cosmos, one mind-blowing question at a time. Space. A word that makes us feel small, curious, and completely amazed. But among the endless stars, planets, black holes, and galaxies, have you ever wondered, what is the most powerful thing in the universe? Is it a black hole? A supernova? Dark energy? Or something we haven't even discovered yet? In this video, we're going on a journey to find out. The answer might surprise you. Before we begin, let's ask, what does powerful actually mean in science? Is it raw energy? Destructive force? Gravitational pull? Or the ability to change everything around it? There are many contenders, and each one is powerful in its own way. So let's break them down and explore them one by one. Supernovae, the most violent explosions in the universe. Have you ever wondered what happens when a star dies? Not just any star, but a giant one, many times bigger than our sun. When it dies, it doesn't go quietly. It explodes. And that explosion is called a supernova. In the next few minutes, let's explore one of the most powerful and beautiful events in the universe. What is a supernova? A supernova is the final, fiery death of a massive star. When the star can no longer hold up against its own gravity, its core collapses in an instant. The outer layers explode outward into space at speeds of thousands of kilometers per second. In just a few moments, the star releases more energy than our sun will in its entire lifetime. Types of supernovae. There are mainly two types of supernovae. Type 1 happens in a binary star system, where a white dwarf steals material from its partner until it can't take it anymore. Boom. Type 2 occurs when a massive star runs out of fuel and collapses under its own weight. Both create massive explosions, but for different reasons. What supernovae leave behind? After the explosion, what's left behind is just as fascinating. Sometimes it's a neutron star, an incredibly dense ball of neutrons. Other times, it's a black hole, where gravity is so strong that not even light can escape. And around it all, a glowing cloud of gas and dust, called a supernova remnant, spreads across space. Why supernovae matter? Without supernovae, we wouldn't exist. Literally. These explosions create and spread heavy elements like iron, gold, and uranium, elements that make up planets, and even your own body. Every atom of calcium in your bones and iron in your blood came from a star that exploded billions of years ago. We are, in a real sense, made of stardust. So, next time you look up at the stars, remember. Some of them might be ticking time bombs, waiting to light up the universe in their final, glorious moment. Supernovae are violent, beautiful, and essential. They are the universe's way of recycling matter and spreading the seeds of life. Title: Gamma ray bursts, the most powerful explosions in the universe. Imagine a beam of energy so powerful that it could destroy an entire planet in seconds, and it's coming from billions of light years away. These are gamma ray bursts, the most energetic explosions in the known universe. But what causes them? And could they ever reach us? What are gamma ray bursts? Gamma ray bursts, or GRBs, are brief but intense flashes of gamma radiation. They can last anywhere from a few milliseconds to several minutes. In that time, they can release more energy than our sun will emit over its entire 10 billion-year lifetime. These bursts are detected by space telescopes and come from extremely distant galaxies, meaning they happened billions of years ago. Types of GRBs. There are two main types of GRBs. Short GRBs last less than 2 seconds and are usually caused by the collision of two neutron stars or a neutron star merging with a black hole. Long GRBs last longer and are believed to come from the collapse of massive stars, a kind of supernova called a hypernova. How powerful are they? A single GRB can unleash 10 joules of energy, that's a 1 followed by 44 zeros. To put it in perspective, That's more than the total output of our Sun over its entire life. If a GRB occurred within a few thousand light-years of Earth and was pointed directly at us, it could strip away the ozone layer and trigger mass extinction. Should we worry? The good news? GRBs are incredibly rare in our galaxy. And even when they happen, the energy is concentrated into narrow jets, like laser beams. The odds of one pointing exactly at Earth are very low. Still, they're a reminder of just how extreme the universe can be. Science and mystery. Gamma-ray bursts continue to puzzle astronomers. They help us study black holes, the early universe, and even how elements like gold are formed. Some GRBs date back to just a few 100 million years after the Big Bang, giving us a glimpse into the ancient cosmos. Quasars, the brightest beacons of the universe. What shines brighter than an entire galaxy but is smaller than our solar system? A quasar. Today on Core of Space, we dive into these dazzling cosmic engines, some of the oldest and most powerful objects in the universe. What is a quasar? Quasars, short for quasi-stellar radio sources, were first discovered in the 1960s. Though they looked like stars, they emitted strange light signatures. We now know they're powered by supermassive black holes at the center of galaxies. As matter spirals in, it heats up and creates a glowing accretion disk, brighter than whole galaxies. How powerful are they? A single quasar can outshine 1,000 galaxies combined, all while being smaller than our solar system. The most powerful quasars emit the energy of trillions of suns, every second. These beacons help us study the early universe, as some formed over 12 billion years ago. Where do they come from? Quasars are born in galaxies with active, feeding black holes. When enough gas and dust spiral in, the black hole erupts into a quasar. Some fire jets of particles across space at nearly the speed of light, shaping galaxies and stopping star formation in their tracks. Why they matter? Quasars light up more than just the sky. Their radiation helps us see invisible gas between galaxies. They act like cosmic flashlights, letting astronomers map the structure of the universe and peer deep into cosmic history. Quasars remind us that the universe is extreme, and still mysterious. They shine from the edge of time, powered by the darkness at their center. Supermassive black holes, giants at the heart of galaxies. Deep in the heart of almost every galaxy, including our own Milky Way, lies a monster. A cosmic giant so powerful, it bends space and time. Today on Core of Space, we explore supermassive black holes, the most mysterious and massive objects in the universe. What is a supermassive black hole? Black holes come in many sizes, but supermassive black holes are in a league of their own. While a regular black hole might be the size of a city, a supermassive one can be as large as our entire solar system. They contain millions to billions of times the mass of our Sun. They're invisible, but their presence is revealed by how they affect everything around them: stars, gas, and even light. How do they form? One of the biggest mysteries in astronomy is how these giants form. Some theories suggest they start small and grow by consuming gas, dust, and even other black holes. Others think they formed right after the Big Bang from massive clouds collapsing directly into black holes. What we do know is that they grow over billions of years, and sometimes, very quickly. Power and influence. A supermassive black hole doesn't just sit quietly. Its gravity can control an entire galaxy. In our own Milky Way, the black hole at the center, Sagittarius A*, has a mass of about 4 million suns. Stars orbit it at incredible speeds, proving its invisible pull. Some galaxies even have black holes with over 10 billion solar masses. When matter falls into a black hole, it heats up and releases powerful radiation. This can turn the black hole into a quasar, one of the brightest objects in the universe. Ironically, the darkest objects in space can become the brightest when feeding. Can they destroy us? Supermassive black holes sound terrifying, but don't worry, they're far away. The one in our galaxy is about 26,000 light-years from Earth. It would take a direct collision with a rogue black hole to pose a threat, and that's extremely unlikely. Instead, they help keep galaxies stable, influencing star formation and galactic evolution. Why do they matter? Visual: scientists observing, telescopes, Event Horizon Telescope image of M87***. Narrator: in 2019, humanity captured the first ever image of a supermassive black hole in galaxy M87. That orange ring? It's light bending around the edge of the black hole. These objects push the limits of physics and help us test Einstein's theories of gravity. Power rankings: the universe's most powerful forces. From deadly explosions to mysterious forces that stretch space itself, the universe is full of power. But which cosmic phenomenon is truly the most powerful? Today on Core of Space, we're doing a power ranking of the 5 most extreme things in the known universe. Supernovae. Coming in at number 5, supernovae. When massive stars reach the end of their life, they go out with a bang. A supernova can outshine an entire galaxy for days or weeks. In a single moment, it releases more energy than our sun will in its entire 10 billion year life. That's cosmic-level destruction, and the birth of new elements. Supermassive black holes. Number 4, supermassive black holes. These invisible monsters sit at the center of galaxies, including our own. With masses ranging from millions to billions of suns, they bend space and time around them. They can eat stars, shape galaxies, and even stop star formation. They don't explode. But their gravitational pull makes them true cosmic rulers. Quasars. At number 3, quasars. These are galaxies with active supermassive black holes at their core, gobbling up matter and shining across the universe. A single quasar can outshine thousands of galaxies. And yet, the light comes from a space no bigger than our solar system. They are distant, ancient, and unbelievably powerful. Gamma-ray bursts. Number 2, gamma-ray bursts, or GRBs. These are the most powerful explosions ever recorded. In just a few seconds, a GRB can release more energy than our sun will emit in 10 billion years. If one went off in our galaxy and pointed at Earth, it could strip away our atmosphere. Thankfully, they're rare and distant. Dark energy. And the number 1 most powerful force in the universe, dark energy. It doesn't explode or shine. In fact, we can't even see it. But dark energy is believed to make up 70% of the universe, and it's driving the universe to expand faster and faster. That's not just powerful, it's everywhere. A mysterious force shaping the fate of the cosmos itself. Power rankings. Let's break it down. For pure explosion, gamma-ray bursts win. For gravity, black holes. For total energy output, maybe quasars. For universe-scale influence, dark energy. So, which is the most powerful? It depends on how you define power. But if we look at what influences the entire universe, dark energy might be the quiet king. The mystery continues. Here's the twist: the universe is still full of mysteries. There might be things even more powerful than we can imagine. From hypothetical white holes to the Big Bang itself, the ultimate explosion that started it all. And what about thought? What about the human mind trying to understand all this? Is consciousness a different kind of power? So, what's the most powerful thing in the universe? Maybe it's not one answer. Maybe it's the combination of forces, from dark energy to the light of knowledge. If you enjoyed this journey, don't forget to like, share, and subscribe to Core of Space for more cosmic content. Until next time, keep your eyes on the stars, and your mind open to the unknown.